Say it again.
Our math.
Hey, this is Mr. Ng going over the pre-calc quiz number 8, chapter 4, section 1, and chapter 4, section 2a. This is the non-trig graphing. And let me zoom in for you. Let's go over the answers and I'll show you some student work. Question number 1 says, what is 240 degrees in radians? So angles are measured in degrees and radians, and we're converting them. So my awesome proportion is degrees over 360 equals radians over 2 pi. So part over whole equals part over whole. 240 degrees goes in there where it says degrees, and I broke down the factors of negative 240 is negative 2 times 120. And 360 is 3 times 120. Those cancel. So basically what I'm doing is I'm just reducing negative 240 over 360, and that gives me negative 2/3. Negative 2/3 equals radians over 2 pi, and then I can cross multiply negative 2 times 2, which is negative 2 times 2 pi is negative 4 pi, and 3 times radian is 3 radians. Divide by 3, and then my answer there is negative 4 pi over 3, and then my correct answer is D. Here's an example of a student who had the formula and they wrote negative 240 and they reduced, but they forgot that it has pi right there. Question number 2, multiple choice, convert the angle in degrees to radians. Express the answer as a multiple of pi. So degree over 360 equals radians over 2 pi, and so my degrees is 45 degrees, that's the given information there. And 360 degrees can be broken down into 45 times 8. So I can cancel my 45s, and basically that reduces to 1/8. 1/8 equals radian over 2 pi, and that can cross multiply. This will be 1 times 2 pi, which is 2 pi, and then radians times 8. Divide by 8 here, and then divide both the numerator and denominator by 2. You get radians equals pi over 4, which is choice B. Here's some student work. Formula substituted, reduced there. Multiply both sides by 8. Oh, I see. Cross multiply, divide, and then divide. Good. Question number 3 says, find the length of the arc of a circle of radius r intercepted by the central angle round to 2 decimal places. So the formula we have is the arc length s is equal to theta over 360 times 2 pi r. Theta represents the central angle, so that's part over whole times the arc. This is the circumference, so basically if we think about it, you're getting a portion of the whole circumference. So with a radius of 20, I'll put that in for my r, and then central angle is 115, and then 2 pi over r to put over 1, and then just multiply across 115 times 2 pi times 20, all of that divided by 360, and you get 40.142. So that would be, if you round there to 2 decimal places, cut that one off because it's between 0 and 4, so that stays. So 40.14, A is your multiple choice answer. Alright, this student drew a picture. I knew the radius was 20, and then the central angle 115, and basically what you're doing is you're finding this particular arc length. 115 divided by 360, 2 pi 20, and they chose to reduce, which you can, and then they hopefully multiplied and got A as their answer. Question number 4 is convert 14.36 degrees to degrees, minutes, and seconds. I break it up to the whole and the decimal. So 14 degrees, and I have 0.36 of a degree, and I'm going to multiply that by 60. The reason why I did that is because I didn't have it, but over 1 degree, so my degrees will cancel out. So there's in 1 degree 60 minutes. So 0.36 times 60 gives me 21.6. This represents 21.6 minutes. I take the decimal, 0.6 right here, and then I didn't do that, but over 1, the 1 here represents the 1 in 1 minute there are 60 seconds, and so these minutes units will cancel, and 0.6 times 60 gives me 36. So 14 degrees, 21 minutes, and 36 seconds. Choice D is your correct answer. Here's some student work here. Looks nice. Because of the multiple choice questions, students may have used their calculators, but remember, when you guys take the chapter test, you'll have a part that has calculator and no calculator. So if this is on the multiple choice, then you're going to have to do it by hand. So you're going to have to know how to convert that. Question number 5, convert the angle to decimal degrees and round to the nearest hundredths of a degree. 25 degrees, 24 minutes, 16 seconds. I break them up. This is already in degrees, so the minutes, it is 1 minute, is 1 degree in 60 minutes. And why I put the 60 minutes on the bottom there is to my units to cancel. Your minutes will cancel there. So 24 divided by 60 gives you 0.4. 24 minutes represents 0.4 of a degree. And then I have 16 seconds, but we're trying to convert all of these to decimal degrees. So 1 degree is equal to 3,600 seconds. And that's why I put seconds on the bottom, because I want those units to cancel. And then if you do 16 divided by 3,600, you get 0.004. And then if you add those together, you get B, 5. The answer for 5. Here's some student work. Did their conversions right there. Looks nice. Alright, backside question number 6. Make sure to show all your work and box your answers. Solve for R, right there. Have both an exact answer and an answer rounded to the nearest hundredth, assuming if you have those. So here I have a right triangle, which I noticed right here. This is triangle TAN, and you have the side lengths of 2 and a radical 5. So the common mistake, I wrote here, the common mistake is to use a 30, 60, 90. Although it looks like a 30, 60, 90, there is no 30 degree angle and 60 degree angle. It could have been like a 31 degree, so you can't use that. But if you recognize you have two sides of a right triangle and you're trying to find the third side, then you can use Pythagorean theorem. C squared equals a squared plus b squared. Then I labeled my triangle. Most important letter is C, which is across the right angle. That is the hypotenuse. And then I just labeled this side A, and this side, that's a B. Plug it in, so A is equal to 2, B is equal to radical 5, and C is called R. So that becomes R squared. 2 squared is 4. And right here, this is where students got lost. What is the square root of 5 squared? That is 2 of them. So radical 5 times radical 5, which is radical 25, and radical 25 is 5. 4 plus 5 is 9. If you take the square root of both sides, R is equal to positive 3 and negative 3. Remember, we're only taking the positive because distance has to be positive. Partial credit there, you got 3 points if you wrote down the Pythagorean theorem, 3.5 points if you did the Pythagorean theorem and you substituted it correctly. Again, the number one mistake is doing the 30, 60, 90 on this triangle. This student, although they got the right answer, they labeled it a 45, which is incorrect. And they try to have 2 answers over here, I think, because that answer is wrong. So I'll definitely be more picky on the next quiz or test. Let's look at some more student work. Here's a classic mistake. They filled in the triangle. Remember, you don't know what that is. You don't know that's a 30, 60, 90. So you cannot use x radical 3, 2x. Here's a student who didn't know what to do, so they just crossed off the work. But I want to actually, they were correct up to this point. They knew it's 2 of them. And radical 25. And here, they didn't know how to simplify it. So the square root is 2 identical numbers that multiply to be this number inside the radicand, it's called. So that number is 5. Here would just be the answer of 5. Here's a student who took in the b value. They forgot the square root. So be careful with your substitutions there. This student said their hypotenuse was 2. Remember, the hypotenuse goes across, so I think I know what they were doing. They tried to say, if you see those marks, that's a congruent mark. They're trying to make this a 45, 45, 90, which would have been incorrect. Question number 7, solve the missing variables. Leave your answer in simplified radical form. So there were 3 variables, x, y, and z, and so I had told you to add an x there. And this one tells us that's 30. So if that's 30 and that's 90, that's 120. 180 minus 120 gives you 60. So y is 60 degrees. Now if I label my triangle, if the 30, 60, 90, the formula is x, x radical 3, and 2x. That means across the 30-degree angle we write x. And across the 60 we are going to write x radical 3. And across the 90 you're going to write 2x. How do I solve for x here? Well, I'm not going to start here because it's equal to a variable. This is equal to itself, not helpful. This is the one I'm going to start with. I'm going to start here because it has a number. And what I can do is if I set them equal to each other, x radical 3 is equal to 9. So it's not saying x is 9, they're saying that they are equal. So right here, what I'm going to do is, to get rid of the radical 3, I'm going to divide by radical 3. I get x equals 9 over radical 3. To get rid of the radical sign, I'm going to rationalize, which basically means you take this and you put it on the top and the bottom. And what that does is if you multiply across, you'll get 9 radical 3. And radical 3 times radical 3 is radical 9, and radical 9 is 3. And then 9 divided by 3 is 3. So you get an answer of x equals 3 radical 3. How do I use that? Well, if I know that this length across the 60 is 9, and I know that solving for x gives me 3 radical 3, then I can just take x equals 3 radical 3, x equals 3 radical 3, and just multiply it by 2. So 2 times 3, that's a 3. It would give you 6 radical 3 would be across the 90 degrees. So there are my answers, 3 radical 3, 9, and 6 radical 3, or if you didn't want to use that, you could have used Pythagorean theorem. So z is equal to 6 radical 3. I put decimals there because it doesn't tell you to round. It just tells you to simplify radicals. So I just wanted to make sure the students were accurate and give you some points. Common mistake is labeling the sides of the 30, 60, how you labeled it was the mistake I was trying to point out here. So if you got one of those, let me see if I can pull that up. No, I can't. How do I make it smaller? I don't know. I'm trying to, let's see. There it is. So if you got one of the variables up there correct, let's just say just the 60 degrees, I gave you guys pretty generous 3 points. If you got 2 of them correct, 3.5. Common mistake was, again, putting those in decimals. I asked for a radical form. Let's take a look at some student work. Alright, let's take a look at this student here. Got 60 degrees, and then they transformed it into decimals, which is incorrect. So that was wrong. I took out some points off. I gave him 3.75. This student did it correctly. I want to show you some correct student work. Alright, this one was a common mistake because the student knew the formula, right? That's why I gave him hopefully 2 points just for the check mark. I gave him a 3. Oh, because they got 60 degrees. 1 correct. And in this problem, they recognize that across the 60 is 9. But they mistakenly thought that it was 9 radical 3, so then they thought, well, the radical 3 is the same, so x is equal to 9, and they put that there, and then 9 here, and they got 18. So, incorrect. Question number 8, solve for the missing variables, round your answer to the nearest tenth. I have this triangle here. Let me see if I can zoom in. There you are. And so, you have a 45-degree angle here. And this is 90, this one has to be 45 degrees. So angle, the measure of angle C, there's C, this is the angle, it is 45 degrees. Okay, if this is a 45 and this is a 45, then opposite of those congruent angles are congruent sides. Which means that if this side is 3, then this side also has to be 3. W is equal to 3. Now in this one, I tell you to round to the nearest tenth. So you could have done a Pythagorean theorem, right? 3 squared plus 3 squared equals z squared. I chose to use the formula. 45, 45, 90, x radical 2. So across the 45, I have 3. Across this 45 is the same variable, so that would be 3. And so if x is equal to 3, then you just put in 3 there, and you get 3 radical 2 to be z. You put that in your calculator, you get 4.243 if you rounded, and then because this number is between 0 and 4, and it stays at 4.2. If you made one mistake, I gave you 3.5. If you made a rounding error, or maybe you chose to put it as a radical and not a decimal, then you got 3.75. Common rounding mistakes, that's to the 10th, and they gave you 2. I think the student was unsure, and so they took some properties of, maybe they thought this was x radical 2, so they thought just multiply by 2. That would have been incorrect. You're multiplying this side by radical 2, not just 2. The student just forgot to write in W. They actually knew it. They even have it on all of their picture, right? And question number 9, find the perimeter of a pizza slice given that the diameter to be 18 inches and the pizza having 8 slices. Round your answer to the nearest hundredth. If you draw a pizza or a circle, a diameter goes all the way across. It's 18. That means each of the radius or radii are 9 each. 9 plus 9 gives you 18. Radius plus a radius equals the diameter. Or if you drew a pizza with 8 slices, you just cut it in half, you have 4 there, and then another one, you have 4 as a semicircle, and another 4, that's a total of 8. So if you got that much, I think I gave you 2 points for the correct form or picture. Formula. So how do you find the central angle here? How do you find x? Well, if you basically take all of the angles, which is 360 degrees, and divided by 8, you get the central angle, which is 45. Each of these angles there are 45-degree angles. Then you use your formula. My formula is the arc length, is the crust. So what I'm trying to find is just, I think it says 1 pizza slice. Find the perimeter of a singular pizza slice. So if I find just the arc length here, then I can just find the radius and add those together. So arc length is equal to theta over 360 times 2 pi r. R is equal to 9, not 18, and theta is equal to 45. Here, if you did one of those substitutions correctly, I give you 3 points. Formula and then one of 2 substitutions are correct. So if you put in like 9 and then you did something like, I don't know, 18, then I gave you 3 points. If you did something like, common mistake was putting radius is equal to 18 and then maybe got 45, then I still give you only 3 points. If you reduce that, you get 1/8, and if you multiply across and then divide by 8, you get 7.07 as your arc length of the crust of the pizza. If you just got arc length correct, then I give you 3.75. You're supposed to take the 7.07, put it up here, and then radius was 9. Radius is 9, so if you add all 3 of those together to get your perimeter, then you'll get 25.06. Okay, this student shows me they thought pizza slice, number of pizza slices is not your radius, and then they put 18 the diameter as their angle. So remember, angles are measured in degrees. They're like inside of the triangle, like right there. Okay, this one looks good. They have the central angle 45, radius is 9, and where they went wrong is then they wanted to multiply their arc length, 1 pizza crust times 8 pizza crusts. Basically, they found the circumference for me. That's what they did, right? Because if I take this number and divide it by 8, which means take off this, and you just have 2 pi r, that's circumference. So I gave this student 3.75 because they at least found the arc length, but just needed to add the radius and radius to get the perimeter of a pizza slice. So they go right there. And then this student has at least the diameter, and then the radius is 9, so I gave that student 2 points. They wrote down a formula: pi r squared is the area of a circle. That would be the whole pizza, like the pizza and the sauce and the pepperoni, like everything inside. That's not what we're finding there. We're finding just the perimeter of one little pizza slice. And at least the student knew that the central angle looks like to be 45. Okay, and then remember, if I'm highlighting right here, if I can, that's the perimeter of the pizza slice. So they knew it was 9, they knew it was 9, and they also put a 9 here. Remember, this is not an equilateral triangle. This kind of curves, right, in your pizza. Remember, your pizza crust curves. So your perimeter would not be just 999. You have to find the arc length there. All right, so the backside wasn't worth 23. I believe it was just 4 points each, so that's 16. And then 16... 16 plus 10 on the front. 16 multiple choice was 10, and then name and period is 2, so this is out of 28. 28 points. Hope that was helpful for you. Good luck.